Hello and welcome to our next video where we're going to do more examples on topic number 4. Let me just insert that here. And in this version, we're going to, let's say here, topic 4. Remember that topic 4 comes in 3 parts, so I'll call this 4.1. This is the B portion where we are just working through some examples. It's the second one. Previously, we have done an example by hand, writing everything out and using your calculator. Now we're going to essentially do the same, but I want to demonstrate how spreadsheet software like Microsoft Excel, but not exclusively, can be used to act as a glorified calculator, if you will. So it's just an alternative. We are practicing the same things as we did in the previous video called B1. So I'm going to do the same problems, just different sub-questions in those. First, we'll look at number 14, and I'm of course, like always, referencing my favorite book to get an introduction to statistics, regardless of your discipline. It is this book that I highly recommend, and we're on page 104. Just scroll a little down here, and I'm going to look at number 14. Let's read it first. In case you have not watched the previous video, you don't need to, but it would help to do these things in order. On a standard measure of hearing ability, the mean is 300 and the standard deviation is 20. Give the z-scores for persons who score a variety of scores, and then also give the raw scores for persons whose z-scores on the test are as follows. Now, in the previous one, we did A and D. Let's just do, I guess, B and E. So first off, we're given a raw score of 310. So let's write everything out here. Given raw score, let's call it X, and we'll put it over there as 310. I'm going to go with the convention. That's how I learned it. Yellow reminds me that it's an input cell. I am given these numbers, and green will be where I perform a calculation using that. Just as visual cues, what went where, how does the question relate to what I'm calculating here? Again, just a glorified calculator, essentially, for our purposes. And we want to find up here the corresponding z-score. Now I reference the formulas in that same book. We have these formulas. Look at 3.1 or 3-1, where we calculate a z-score, the raw score minus the mean over the standard deviation. So we'll use this formula in Excel. So let's say here, z-score, I'll put it over there. I'm going to color it green to remind myself this is a formula cell where I do a calculation. So now let's do it. In brackets, the numerator takes the raw score. Before we do that, I jumped a little bit ahead of myself. More things are given, right? Let's move these things down a touch. We have the mean. Got a little bit excited. What was the mean? Where's my question here? 300, standard deviation 20. So I'll put in 300. That's also important. So that gets a yellow. Standard deviation like that. That was a 20. That's also part of the input. Now I'm ready to calculate my z-score. Numerator takes the raw score minus the mean. All of that gets divided by the standard deviation, and we are good to go. Z-score of 0.5. Just like we did with a calculator, just in sort of a spreadsheet, more presentable, easier to manage layout. Let's look at, so I can again double click on this to highlight which numbers did I use and where, if I need to edit anything or double check it. Next, the beauty of this, let me just highlight, if I now have part C as well, where the raw score is different, but the question is the same, I can recycle my work here and say, okay, maybe this was just my calculation stuff. Let's put B's answer over here as 0.5. And let's put C's answer over here. And I can recycle this to now say, okay, I'm just going to change my raw score input cell from 310 to 260, and my formula will update to -2, and I can put my -2 answer in there. So this is sort of my calculation area, and then I can write the answers as I get them. I don't have to recalculate everything. That's the beauty of it. The calculation is still in there. If I need to update some of these input cells, I can very easily do that, and the calculation, the answer will update as well. So let's do that perhaps for the next one as well, where I am given the z-scores. We'll do E and F maybe. And actually, no, I'm going to do E and G. F is super easy. And I want to calculate the raw scores. So let's maybe, just to separate these, let's do the mean again. It is the same, I know. We could have used the top one, but just to keep them separate, so those two are input cells, the color makes it easier for me to see, not necessary. Now I'm given the z-score. And in the first one, they are wanting me to use 1.5 for E. 1.5. That's another input cell. And I'm going to calculate the corresponding raw score. Let's call it X. And that will be my calculation cell. Now remember, how do we do that? Well, the formula might not be directly given here, but it is just a shuffling around, a rewrite of this formula 3-1 that we've also seen in the previous one. I'll write it down maybe for you. If I now solve for X here, the standard deviation gets multiplied by the z-score, and I add the M just sort of as a reminder here. But we're not going to use that. M plus z-score times, let's write it like that. So that'll be my reminder, but it still comes from that same formula. I start with an equal sign, and I take the mean and add the z-score times the standard deviation. And I get 330, which I maybe want to put in there as my answers. Then I can also do F, for example, and recycle that. In F, we have, not F, no, not F. F is super simple, 0, so the raw score will be the mean. Let's do G, where it's not super obvious. A z-score of -4.5. What is the corresponding raw score? Then I can simply put my -4.5 in here, and the formula will update to 210, and I can write my answer over here somewhere. So the spreadsheet convenience should become obvious the more we do it, and the more we have to do similar calculations over and over. We don't have to write down all the calculations every single time. All right, so that is question 14. Let's do question 16. And it's a little bit lower over here. Can we zoom in on this question? I think so. That looks pretty good. The amount of time it takes to recover physiologically from a certain kind of sudden noise is found to be normally distributed with a mean of 80 seconds and a standard deviation of 10 seconds. This should be familiar because it's the same question we did in the previous video. Using the 50, 34, 14% figures, approximately what percentage of scores will be above 100, below 100, above 90, below 90, and so on. Now, previously we did A, B, C, and D, so let's maybe do E, F, G, and H. But first, remember what do these rough figures represent? Now, drawing here is not as convenient as it might be by hand, but let's do a rough illustration of the normal distribution. Let's put it over here. Very rough. I'll just sort of do a bell curve like so. Doesn't have to be the best. There's my bell curve, just as a reminder, right? And then we can have, I know it doesn't actually curl up there. Very rough, very rough. I draw a couple of lines here. That is not what I want to do. Undo that. Let's maybe go just a couple of lines. I haven't worked with this very often. Like so. There's a line there. Let's go to the right side maybe. There's a line there. And this will be where the 34% sit. Not there. Like that. And then maybe another little line, very rough. Of course, doing this by hand would be arguably much easier. Like so. And then maybe I'll put my 14% over there. And then the last part here will be 2%, and everything will be the same on the other side as well, of course. But to save time, I'm not going to have you watch me draw all the little lines. Just a rough reminder. If you can't see it in your head, definitely draw it, scribble it on a page. So now I want to know, well, stuff is given, a mean of 80 and a standard deviation of 10. Let's maybe take note of that. Let's make some space here because it's separate from the questions. Specifically, a mean of 80, standard deviation of 10. Let's put another line here. These are input, so I don't miss them. I make them a nice, recognizable, noticeable yellow. First of all, we want to see, well, what's the question? The question is in C. Roughly, what percentage of scores will be above 90? I want to convert that 90 to a z-score first. Now I can do a raw score and then calculate the z-score as, oh no, sorry, no calculation. The raw score is input, 90. Then I'll calculate, right, 90. And then the corresponding z-score, we'll do a calculation there. And that'll be the same as before. Raw score minus mean, all of that divided by standard deviation. And I get a 1, which makes total sense. It's one standard deviation step away from the mean. So now I should put my numbers in here, but this is the 0, z-score, 1, 2, and beyond. So 1 puts us over here. So roughly, rough percentage above. Let's put that over there. That's what they want, right? Above 90. Well, my z-score puts me over here. So above that will be 14 and 2%, so 16%. Roughly, I'm just going to move this one down. But like before, we can also try and be precise. I'm just going to leave that for now and do all the rough ones first. Then we'll loop back and do all the exact percentages, so we don't flip back and forth if this is a little new to you. So let's just do all the rough percentages first. Next up is below 90. I can very quickly answer that. Rough, I guess we can just recycle the work done in E. Rough percentage below x equal to 90. Well, if 16% is above, then 84% will be below. And then we can do an exact one later. And in part G, they want above 80, above the raw score of 80. So now we can copy this over. It's not a big deal. If we want to keep the questions separate, of course, my formula copies over and expects numbers to be there. I need to adjust that. So because the yellow input doesn't change in terms of the mean and standard deviation, I can update this guy to say, let's have the raw input. I'm going to have a new raw input, but the mean, which is B3, I will fix that cell by pressing F. Put my cursor in, then press F4, as well as the standard deviation cell. Then when I copy this, just copy and paste, I see that it is using the same mean and standard deviation cells, but the raw score has moved with me, so that now when I want an 80, the calculation updates, well, of course, to 0, right? Is there a more interesting one than 80? I mean, if the mean is 80, then above 80 will be 50-50. So that seems a little silly in hindsight. Let's maybe do 70. Let's do G and H. That's more interesting. Oh, I thought about that in advance. G and H is what I want to do. So 70 it is. And I get a -1. So again, using this is much more convenient than a calculator in that I can copy formulas and input and reference different things and fix them and move them. Once you get used to it, it is extremely convenient. So now I have a raw score. I'm just going to scroll a little bit. Raw score of -1. I'm just going to copy this so I don't waste your time typing. The rough percentage above this, so I'm over here and my line is over here. Maybe I should draw that line, huh? Yes, let's not be too lazy. Put that line over there and just make the other line to be complete, like so. So then I have my z-score of -1 over there. I'm looking for above. So it's half the graph, which is 50, and another 34 sits over here. If you don't even want to do that, you can say, well, we can do that in our head, right? It's 84 rather. 84% sit above this line over here. 50 because of the half, the top half, and then another 34 over there. Exact percentage, we're going to get to that. And then we can use that for the below. Just going to copy this and this. But I need to update the 90 to a 70. So the rough percentage below 70 will be below this line, which will be my 16%. And because of the symmetry, we have very similar answers, right? Sort of flipped around. Okay. So we can use a spreadsheet for a convenient calculator. Let's go a little further. Because Excel has built-in functions, the normal distribution and the table that previously we had to look up, this is all built in as a function in Excel. So instead of looking up in the table, I can use that. If you compare it to how we did the exact percentage previously, we used the table. Now we're going to look it up, quote unquote, with an Excel formula. So let's just remember in E, what were we looking for? Our z-score was 1, so our line is over here. We're looking for above, but we need to find the exact z-score. We need to find the exact percentage that corresponds to that z-score of 1. The z-score is exact, it's 1. What is the percentage really? So if I think about what we're looking for, we can look for above or below. Doesn't really matter. I'm just thinking of my spacing here. Just make some space here, maybe another line, not sure. Let's move that back to where it was, just because I need to do some calculations here, perhaps. So instead, I'm going to look at the percentage below. I'm always going to look at below, and then if the question wants me to do above, I could just flip it around and subtract it from 100%, right? So what we're going to calculate here is, I guess it is this, what I'm looking for. The exact percentage below is what I'm going to do first. The way the formula is going to work, I'm always going to look for the left up to a point called the cumulative distribution, everything up to a certain point. So we're going to maybe look for a function. Let's suppose we don't know. We can click on the function, insert function button there, and search for, oops, if I can type, normal. It's a normal distribution, and a whole bunch of things come up. I'm looking for the norm S distribution and the norm S inverse, depending on which way I want to go. There is the normal distribution as well, where you can put in the mean and standard deviation. But to match it with what the book table does and what we do with that table, I'll use the standard normal distribution. So let's read the description to figure out which one is appropriate for us. So the norm.s.dist says returns the standard normal distribution, whereas the so I see here I put in a z-score, whereas the other one returns the inverse of the standard normal cumulative distribution, where I put in a probability or a percentage, and it gives me the z-score at that line. So in this question, we have the z-score, and we want the distribution, the probability, the percentage. So again, if we look at the diagram here, I'm going to tell it, okay, let's put that in, see what our inputs are. What is the z-score? I can type in a 1 for sure, or, oh, don't do that. Escape was not what I wanted to press. I can type in a 1, or I can reference that cell over there. It's really all the same. Just for now, for simplicity, I'll type in a 1. Cumulative will always be true. because we want to have it sweep all the way to this line. And it's only going to be able to do the from left up to a point. So it's only going to be able to do below, but it's really not a big deal. Below is what I need to calculate. In this case, above is the one they're looking for. I can then simply say, okay, it's 100%. Take away this one. Now, let me just backtrack and edit this. It rounded everything way too much for me. Let's go 2 decimals, right? That's much better. I don't want it to round to the nearest percentage because then I can't tell the difference between my estimate and the exact number. So having a couple of decimals show that they aren't the same. 16 was very close, but it's in fact 15.87. Okay, so let's just double click on this, not this one, to remind myself what the function was. Now, I'm not typing in this function and remembering all the arguments. I'm using the insert function to guide me through what the input should be, what the function is trying to do. I don't have to memorize these things. I only remembered this is a normal distribution, and from there on I explored according to the description. So now, ironically, we happen to have the answer to F already because it wanted the percentage below. So the percentage below is what we had to calculate first anyway, without necessarily thinking about the question, because the cumulative distribution is always going to go from the left to a point. But the questions could have been swapped around, so I don't know. So in the, let me move this so we can see this down here as we move on to part G. So perhaps it would make sense to do H first, because that's the below one, and then very easily use that to calculate the top one. Let's try that. Let's just go down so I don't even think about the previous one. So I'm going to do H first, because the cumulative distribution, the Excel function, does the below part anyway. So the exact percentage below Z equal to -1, space missing, is what I'm looking for. So now I'm not going to remember the function. What if I make a mistake? It's a hassle and it wastes my time. I remember, oh, it does show me recently used functions, but this is, maybe I don't remember that at all. I'm going to search for normal. None of these sound right. Normal distribution, standard normal distribution. Those are the z-scores to represent the tables that we're familiar with. Really, it's just looking up the table. So again, I'm returning the standard normal distribution, the probability, the percentage, cumulative, given a z-score. And in this case, my z-score is -1. Doesn't really matter. I'm just going to reference that one in case in a bigger question, maybe I am going to update that. Then everything is connected to the original input cells. Cumulative will always be true for our use. And we get our, looks a little too many decimals. I'm going to right click and format that cell to just be percentage showing 2 decimal places, so it's not too messy. Now the beauty of this is that because I referenced the z-score cell, if there's another question, which I think there might be, if you wanted to do the 61 below 60, you can recycle that and just say over here, what if that's a 60? Then the z-score changes as well as the percentage, because they were all linked to the input cells. And I'm more efficient in that way. Let's go back to the 70. So this is my estimate was 16. In fact, it's exactly 15.87. Now I can actually go up to the above and say, well, this is simply going to be 100% minus this below number. Now, of course, it doesn't want to automatically go to 2 decimal places, which would be nice. Sometimes it does, sometimes it doesn't. Like so. Showing that I was very close with my estimate. It's very good, but it's not exact. And depending on what I'm trying to do, we want to be exact and use our rough 34, 14, 2 percentages to just get a sense of, is this what I expect? Yes or no, and then I can double check my calculations. Alrighty, so we're moving along. These introduction examples take time, but they're very important to get a sense of the distribution, raw scores, z-scores, all those things, percentages and sections under the normal distribution. I want to do one more. Question 17. 17 is over here. Using the information in problem 16, so we again have the mean of 80, standard deviation of 10. I'm now just flipping the question and asking what is the longest time, the raw score, so that I will be in the bottom 2%, 16%, and so on. Now, previously we did, I believe, A and D. So let's maybe do B and E. Is that what I marked here? B and E. Beautiful. Now, not to overlap with the other question, I'm just going to give myself some space and remember the mean and the standard deviation. What was it? No, go all the way up. 80 and 10. 80 and 10. Those are inputs, and I remind myself, just a good habit to get into. So now I want to work with 16%, and I want to be in the bottom 16%. So now let's say the percentage below is 16%, like so. Now let me just copy over this very rough diagram so we can have a look at it again. I know, it's beautiful, isn't it? Love it. You can do it in your head, close your eyes and visualize all these things, but it's nice to have something to look at. Now, what do I want to know? I want to essentially use this 34, 14, and 2 rough percentages to figure out which z-score, score I would be at to have a 16% below. Well, 2%, 14%, so it'll be a z-score of -1. And then I want to say what is the corresponding, still rough, raw score, let's call it X. For that, I will use the formula, of course, the mean plus the z-score times the standard deviation. Now, I didn't color the z-score green because I just sort of did it in my head. I didn't use a formula, but you totally can. Totally can. Doesn't matter. It's just the color just guides me. When things are a little bit bigger and more involved, I can keep track of what I've done. Let's look at E. E, where's E? 98, so the bottom 98%. So I want percentage below, and I want 98%. I use my rough figures to guess what the corresponding z-score will be. It'll be over here, 1, 2. Then the top is 2%, so the bottom is 98. It'll be a z-score of 2. I can then calculate by reversing this formula 3-1 to calculate the corresponding raw score X. Now I can do it all again, or I can go and update here, realizing that the mean is always the mean, fix that cell. Standard deviation is always the same, fix that cell, and then I can just copy, and paste. And then you see it has updated the z-score because it was in the same relative position, but the original mean and standard deviation are still used. All right. And it makes total sense because from 80 to standard deviation steps will be 20, putting me at 100. All right. Let's now say, let's give myself some space here. I want to calculate exactly what the raw score is. Well, I have the percentage, make that yellow. That's an input. They give me, whoopsie, here. They give me 16% is what I am looking for. I now want to calculate exactly what is the z-score such that it's not exactly this line. What is it exactly so that the bottom part will be 16% exactly? So I go to my insert function. I know it's got something to do with normal distributions. Maybe I do remember, maybe I don't. I remember some. Okay, so this one is where I'm given a z-score and I want to find the percentage below. That's not the case. The inverse is the flipped around version, the reverse. So I'm given a probability, returns the inverse of the standard normal cumulative distribution, so everything below. That's what I want. So we are guided by just the probability. Now I can reference, I can put in the probability, or I can reference that. Just be careful with percentages. It should read it when it does a calculation. The general rule that you can go with is a calculation doesn't use a percentage. It uses the decimal equivalent of a percentage. And a probability is not a percentage. It's a number between 0 and 1. We multiply by 100 to make it a percentage for presentation and convenience. But when I do a calculation, I always go back to the corresponding decimal number. So if I put in my number here, I should put in 0.16. However, these days, the software and the calculators are, I don't want to use the word intelligent, but they understand the switch and does that automatically for you. So if I reference that cell, I'll get something similar than if I did 0.16. However, just be aware that it's not a given, and I should be careful. Was it exactly the same? It gives me here a preview. Let's just do this one. Negative 0.9944. Now here, it's not showing me an overwhelming number of decimals, so I don't care about rounding it necessarily. It is a final answer. You totally could round it. Notice that it's not exactly negative 1 rather. Let me just see here. Let me just do it there perhaps, and just want to see, did it do the exact same thing if I reference the cell as input? Yeah, okay, it did. So it converted the percentage. In the background, it's not a percentage, it's 0.16. Percentage is just for presentation. But just be aware that depending on your calculator, outside of a spreadsheet, even within Excel, I'm a little suspicious. I'd rather be in full control and know exactly what is happening. Then the rough score is something I could just copy here, because my formula here was using fixed mean standard deviation, z-score right above it. So this one will as well. Same formula, same everything. You see it's just slightly different from my guess. My guess was there for convenience. I knew it wasn't precise, but it was very close. And you can then round this as you want. If I round too much here, I might see a -1 in both and think they're the same, but they are not. Okay, so let's practice that again one more time. Now I'm going to go exact z-score using the given 98%. Maybe I don't remember. Yes, you can copy that formula. For practice sake, I'm going to remember. Okay, so I don't know which one it was, but you can look at the explanation here. The norm.s distribution gives or takes a z-score as input. That's not what I have. I have a probability as input, and it gives me back the z-score. Okay, that's what I want. And I can put in here 0.98. Or I can just reference that cell. It's the same. You can verify that it's the same by way of the preview answer it gives you here. It's a little small, but it's there. And I get an exact z-score of 2.05 and some other decimals. Not exactly the 2 I guessed. That's okay. Rough score, I'll just copy that to save myself some time. That's the beauty of the spreadsheet. Double check by double clicking on it that it is using the right cells and the right formula. Don't take it as a given. And I see that my 100 was close, but it's not exactly right. All right, so that should give you an alternative way to perform these little calculations around the normal distribution. Using a spreadsheet, it's just a matter of convenience. We can, yes, of course, the functions here are more precise than our tables because we are missing some stuff in between. But it's essentially, to keep things simple, we're essentially doing the same thing. The tables are just quote unquote built in to Excel by way of these functions. So it's a matter of convenience. I'm just giving you options, and by looking at these options, we've practiced more of these questions as well. All right, that is the end for now. Until next time.